Hello. So, we will continue our discussion on computer networks and internet protocol. Today, we will be discussing on data link layer, rather we will be having a series of lectures or discussion on data link layer. So, as we have seen that data link layer is the one of the predominant layer in both OSI and TCP IP protocol stack. It is in the level 2 or layer 2 in the stack. And as we are coming in a top down approach. So, we have discussed on application layer, then transport layer, network layer, then now the data link layer, and then we will go for the physical layer. In some of the literature or some of the references, you will find that data link layer and the physical layer are dealt together, because there are a lot of especially the IEEE 802 stack considered them together. So, there are both way it is dealt. So, what we will see, we will try to look one after another, but no harm in looking them together also. So, we will just come back to our slides which we have seen much earlier at the beginning of the lecture. So, if we look at the OSI protocol stack, these are the 7 layers, and if we refer to this data link layer, this transfer of unit information, framing and error checking, or error and flow control is one of the major aspects, and down the below is the physical layer, which is basically transmission of the binary data through the medium. So, this is our protocol stack. So, and if we again if you recall, so if we see that if two end systems A and B are communicating, so a application, say email application or HTTP applications, when it goes through this stack and finally push through this physical, and then goes to this is a layer 2 switch, there is a layer 3 switch or a router, again layer 2 switch, and go on. There can be multiple hops of the things. Finally, it is another application that if it is the email, there are this email application going on, this PRA applications talks to each other, or any applications going on, PR applications over the network talks to applications talk to each other. Now, one as we know, or we have already discussed, that intermediate layers, these devices are open up the layer or the packet up to which it is enabled, right. In other sense, this is the whole stack of things, like application data payload goes to the transport layer as a payload, then with the header etc., goes to the network layer as a payload, then the data link layer, physical layer, and when it is coming to the layer 2 switch, which understands of the data link layer, it opens up to the data link layer and see that where it need to be forwarded, goes to this one and go on so long it is not reaching the end systems, right. So, that allows us to achieve interoperability, right. So, we can have intermediate switches and routers of different, this is layer 3 capable or layer 1 to layer 7 capable devices, which open up the packets up to this and check that where things to be which to be moved. Couple of things we want to discuss, or just to recap, that when we look at a network layer, so it divides the network, right. Like IIT Kharagpur is a network, then say some other, say IIT Bhubaneswar, IIT Delhi, Jadavpur universities and type of things. If we look at the academic institutions, these are the different networks and type of things. So, there is a router which goes on the things, right. Also, we have discussed about autonomous systems and traffic moving from one autonomous system to other. Nevertheless, if you see, if we want to send some data, there should be a physical connectivity. It can be wired, it can be wireless, it can be something line of sight, or it can be through satellite or something, right. But there should be a medium by which the transmission should be done, right. So, whatever you want to transmit, it need to come to the down level, right. So, if we look at that, if we look at the last 3 layers. So, if we look at the network layer, it divides the network, or in other sense, as we have discussed, it divides both the collision domain and the broadcast domain, right. The broadcast is not heard by the other side of the network, neither the collision things are there. If we look at the layer 2, it basically in the same broadcast domain, but nevertheless that divides the collision domain. So, it gives us a better efficiency. If we look at the layer 1, then it is in the same collision domain and broadcast domain. So, the efficiency is much less. So, what we are trying to primarily focus on this couple of or series of lectures is that what are the different things what we go to the layer 2 type of device. So, just to again remind you that if a router is sending a packet to another router, right, the logically it is in the network, again it has to find out, but nevertheless finally it has to come to this layer 2, find out that layer 2 addressing scheme and go push to that particular other interface of the router. So, even to layer 3 devices, when you have to communicate, it has to come back to layer 2, look for the layer 1 for the physical media and get the things transmitted, right. So, it plays data link layer is inevitable, as in some references we have told. We will be again discussing those things. There is a protocol called Address Resolution Protocol or ARP, by which this is the intermediate protocol what we say that between a layer 2 and layer 3, which if given a IP address, it finds out that what is the layer 2 address or the MAC address at the MAC address, so that it can be transferred to the next thing, right. So, if we look at the protocol stack, so this data link layer and physical layer sometimes considered as a combined layer, where the predominant protocol is the Ethernet. There are other protocols, but the predominant protocol here is the Ethernet protocol. So, if we see that the data link layer, so above it is the network layer, down is the physical layer. Again I am repeating, in some of the consideration we take that data link and physical layer together. And if we look at the data link layer little deep, and so what we see that it has two sub layers, one is MAC sub layer, another is LLC sub layer, that is medium access control sub layer and logical link control sub layer. So, one sub layer, that MAC, is primarily for accessing the media, that how the access mechanisms will be there, and logical link control is more of the, it defines the service access point with the upper layer. In differentiating these two allows the thing that there are different MAC mechanisms or protocol can be used for a given LLC and type of things, right. So, this is two aspects of the manageability. So, like just to pictorially show you, so network layer, so this LLC sub layer and the MAC sub layer, right, and this is the physical layer. So, they take care of that connectivity with the upper layer and the down layer, means layer at the bottom of the things, right. So, again just to repeat, we have two applications which it may be running at different systems of the same system. For our consideration, we say that over the network it is running, and then these applications how they will transmitted will be through the transport layer. So, transport layer identifies the process of the two things. So, we require the IP address plus port, what we have discussed while discussing on the socket, forming a socket connections, IP address and port. We have then the network layer which find out the logical connectivity with the help of the IP address. We have that data link layer which is a hop to hop connectivity, right, that every hop the next data link layer address need to be resolved or the MAC address need to be resolved, packet need to be passed to the things. Like if I have a n number of routers in my path, then every router I to I plus 1, the address of the router I plus 1 need to be resolved or find out that what is the MAC address or the layer 2 address or sometimes known as the hardware address, push this traffic to the next hop and it goes on the hop by hop connectivities, or as in commonly say that it is within that local area network connectivity, it is in the same broadcast domain, but the collision domain is a different collision domains. Now, there are some of the issues, challenges, problems what we say, like one is the sharing a wire, right. So, I can have two things to connect a host, one wire connecting a host, like we will see that if I have two machines which wants to communicate, I may not require so much layers of networking. I can have a wire which can physically connect these hosts, and I can have a say swap of the trans receive things, and it can be connected, right. But if I have more hosts, then the connection will be somewhere like that, right, or it will be everybody is connected to everybody. This is a switch network, this is a type of things. So, whether I can how to share on a wire, that means whether I can have a bus and then go on connecting systems on the bus, right. So, I have a sort of a backbone bus and then connectivity on the thing. So, that is one issue. Other issue, usually what we find that when we talk to, when we discuss that somebody talks, others listens, right. So, listen before you speak, or right, it can be things, but it may so happen that if you do go on simultaneous speaking, right. So, this is another challenge, right. So, there will be collision and requirement, we need to speak out what we are talking again. So, we have to speak out again, and which results in retransmission. If there is a retransmission, then there is a loss of bandwidth, right. So, on a particular given time, you how much things you could have transferred. If you are going on retransmitting, there is effectively you are delaying or losing, or in effective terms you are losing bandwidth, right. So, in other sense, if there are multi-party talk, which may be a case when we share a things like this, right, when there is a common bus, you have number of systems, then what we see, then there may be a scenario of collision, right. So, another issue is, so there will be a issue of collision. Another issue, recipient of the packet need to put an address on the packet. So, there should be addressing scheme, right. If I want to transmit from here to here, or this fellow transmitting to other fellow or the same fellow, there should be addressing scheme to identify the destination. So, need to a address of the packet. So, what should be the overall format and type of things, that is a issue, or there is a something to be resolved. How do you know that what address you want to send it to, right. I have a logical addressing, right. I know that logically I know that thing. So, which will be the physical address, or which address I need to send, those things need to be I need to know, right. So, that is this is other challenge. So, if you look at the data link layer, they need to resolve these things. So, if we now come to that medium access and medium access control. So, MAC sublayer is primarily used in broadcast and shared channel network. If I have a peer to peer network, it may not have that much utility, right, because it is a, if it is a point to point connectivity, then I do not have that type of utility. MAC protocol enables two station on nodes using a shared communication resource to establish, maintain and terminate connection, right. So, it is a protocol which is when two nodes or two given two stations systems wants to communicate to each other, they shared a media and they want to communicate with each other, and then the MAC protocol should be able to establish, maintain and terminate a connection. So, it should have a way to connection establishment, maintenance and terminating. Something analogy you will find in case of our connection oriented service in the transport layer, where also we have this sort of a stuff where need to be a connection establishment, then maintenance and termination. Also you might have seen or look at the things when we look at the socket type of things, where those things are required. Those are analogy, but here also we require a things to be communicated, right. So, things are there, and there can be different type of scenarios. The predominant is the Ethernet what we are using. It can be through cellular connectivity, even it can be through your satellite connectivity, right. So, or any type of media which allows you to connect through this through some media. And if we look at the standard, IEEE 802 is the predominant standard which are used or which are practiced these days over across the world. And if we look at so if we look at that OSI or TCP IP layers per se, if we look at the physical and data link layer, so the OSI layer, then we have this MAC sub layer and LLC sub layer. And if we have the standard, so Ethernet is the predominant standard here 802.3, and that this looked as the CSMA CD, or there are standard for 802.4 of token bus, 802.5 of token ring, or FDDI. So, there are different type of standard, but our again as our predominant standard is CSMA CD, we will be primarily looking little more deep into this type of in this technology or in this particular protocol, right. So, this is the, so what we have a standard to support this, and any say network device manufacturing following these standards will enable us to connect the devices across each other. So, that is interoperability between devices from different make or connecting at different layers etcetera are guaranteed or ensured by this use of these standards, right. So, this is a important thing to know, though these days token ring and token bus are not so popular. So, most predominant is the Ethernet protocol, and we have from 10 Mbps, 100 Mbps and gigabit Ethernet at the Gbps level. So, if we see that 802.2 is the primarily handle the LLC, 802.3 is the CSMA CD or the predominant Ethernet protocol, 802.5 is the token ring, and 802.11 series is primarily for wireless LANs or wireless connectivity, right. So, rather in wireless domain we follow a protocol of CSMA CA, we will look into those things in our subsequent lectures. So, if we look at the scope of the 802.802 standards, if you look at it spans from this data link layer to physical layer. So, those type of things. So, as we are discussing that LLC has the different what we say the service access point for different service access point for the upper layer protocols, and it basically communicate with the MAC layer. MAC layer in turns communicate with the physical layer. So, one sort of thing is that I want to know that which is the MAC layer of the, there should be addressing scheme for the MAC layer of the destination machine, and also there should be some sort of a addressing per se for this LLC to talk to the upper layers, or in other sense there should be some sort of a service access point reference type of things. So, these things are needed for while I want to communicate from one system to other system at the data link layer. So, if we want to see that 802 layers functionality, so at the physical layer portion which we will be discussing in some time little later in this series of lectures. So, physical layer is primarily concerned with encoding and decoding of the data. So, preamble generation or removable as and when it is means as applicable, right. So, based on where transmitting or receiving and type of things, bit transmission and reception, and transmission media and topology, how things are there, that is the one of the these are some of the primarily functions of physical layer, which is governed by the 802 standards. And in the logical layer control, interface to the higher layer is one of the primary thing, and flow and error control is another aspects of LLC, whereas in the MAC data assembly and dismantle into the frames, right, govern access to LAN transmission media, that how that data to be there into the media, right. So, these are the things which we require. As we are familiar with LAN card or network adapter type of things, that primarily in a PC or laptop or whatever the your device is. So, this network adapter card, all LAN card or type this whatever we heard is primarily enables this your functionalities of data link layer and some of the physical layer things like interface with the means physical layer. It may be a WAD, it may be wireless, it may be Bluetooth, Zigbee or anything, satellite communication and so on and so forth. So, if we look at the LAN protocol, so two end stations, so end systems that communicate via shared LAN, right. So, higher layer protocol above LLC provide a end to end service between the station, right. These are the higher layer protocols. So, in case of a logical link also we go through this LAN, but it is also a end to end connectivity, whereas the media access and the physical is basically utilize this LAN infrastructure or the connectivity to communicate between each other. So, that is the goal of the thing. So, if we look at the LLC, so it is a LLC layer for LANs is concerned with the transmission of link level protocol data unit or PDU between the two stations without the necessity of a intermediate switching node, right. So, the LLC layer of LAN or LLC layer of the data link layer DLL data link layer is concerned with the transmission of the link level at the data link level PDU, right. So, or protocol data unit between two stations without the necessity of a interface of a switching node. So, it can transmit the things, or in other sense that protocol data unit will contain the payload what it gets from the higher layers, right. So, it is that the data along with the whatever the network layer header and footer and whatever is there, header and trailer, it comes as a payload to the data link layer which transmit to the next device or next hop, right, by finding that what is the next hop address and transmitting the data, right. So, that is the basic bottom line of the thing, and there are two characteristics. It must support multi access, shared medium nature of link. So, these are the things what we expect from the data LLC or the data link layer protocol, and it is relieved from some details of the link access to the MAC layer. So, in other sense LLC, some of the things that media access things are pushed into the MAC layer. So, it takes care of the MAC layer. So, if you look at conceptually, so the data link layer is to LLC and the MAC layer. The MAC layer takes care that negotiation or interfacing with the medium, underlying medium or the physical layer, whereas this LLC is primarily involved or concerned about how it communicate to the higher layer, or in this case the network layer, how it will concern to the things. The rest are taken care of the things. Only it need to be ensured that the medium can be shared, right, and then and multiple shared means it will be multi access nature of links. Now, there are different category of LLC services. Some may be unacknowledged connectionless service. So, it is something datagram style what you have looked into the IP, does not involve any flow or error control mechanisms, and data delivery is not guaranteed. So, it is some sort of a best effort service what you have seen that in case of a datagram, right. Another is the connection mode service. A logical connection is set up between the two stations, flow and error control are maintained. There is a connection oriented type of service. Another is an acknowledged connectionless service, right, across so between a cross between the two previous services, right. So, it is a acknowledged connectionless service, right. So, some sort of guarantee is ensured, datagrams are to be acknowledged, no prior logical connection setup is required. So, this different mode that LLC type of services can work on, right. So, unacknowledged connectionless service, connection mode service, and or connection, some sort of a connection oriented service, acknowledged connectionless service. So, if we look at the MAC or the medium access control, so assembly of data into frames with address and error detection fields. So, that is one of the major aspects, assembly of data into frames with address and error detection fields, and deassembly of frames and performing address recognitions, error detection and other type. So, it is it takes care that I have the MAC at the sender and the receiver. So, it need to put the addressing things of the destination hop along with the frames and the error detection fields, etc. And on the other hand, it has to extract and also check that whether there is a error request for retransmission is there, and type of things can come into play. Governs access to transmission media, that is one of the major or one of the major aspect or major concern, that it governs the access to the transmission media. For the same LLC, several MAC option may be available. There is another interesting part. So, you have the one LLC, but you can have different type of MAC options, right. So, or MAC mechanisms for the same LLC, means dividing them or into two aspects, that one LLC for the higher layer connectivity and MAC for the physical layer connectivity. What we achieved, that you can have now number of solution of this MAC for the same type of LLC. So, if we look at the medium access layer, so all LANs consist of a collection of devices that must share network transmission capacity, right. So, whatever LANs or at the layer 2 level network we are considering consist of a collection of devices that must have a network transmission capability. What we see, that if you have a PC, it should have a network interface card. If you have a network printer, it should have a network interface card. Anything which has a capability to communicate with the network has to have some way interfacing with the things. Function of a medium access control protocol is some means of controlling the access to the transmission media needed for efficient use of the capacity, right. So, what is the basic function of the protocol? That there is some sort of a controlling mechanisms, so that it can, first of all, it can transmit through this shared media or multiple access type of things, and the media is maximally used. So, that means the bandwidth which is available can be used in a maximum terms, right. So, if we look at, there are two things we are looking for, where and how. Where refers to whether the control info is exercised in a centralized or distributed fashion, and that means in case of a centralized, we have a controller has the authority to grant access to the network. So, there is a controller, centralized controller, that who says that where things will be, how things will be accessed, who comes after whom and type of things, and there is a distributed station collectively perform a MAC function to determine dynamically and the order in which the stations transmit, right. So, one is centralized, there is a master controller which takes care of that how the transmission will be there, or that is distributed, that means there is a some sort of a consensus protocol or way that the stations transmit to each other. And how is constrained by the topology is a trade off among the competing factors like cost, performance, complexity and type of things, the how the transmission will be there, right. So, overall if we try to look at that again the protocol stack. So, we have the application data, right, which along with the TCP header at the transport level. So, it accumulated. So, the application data payload application data becomes a payload to this TCP layer. It adds its header, trailer, whatever it wants to add, and along with the TCP header, it goes to the as become a payload for this IP layer, when the IP layer header is added, and then it becomes a payload to this LLC or what we can say overall a data link layer, and then this MAC along with that whatever is coming with the MAC header and trailer become the MAC layer frame. So, what we say that TCP segment, IP datagram, LLC PDU and MAC frame, or sometimes we say that layer 2 frame which consider both LLC and the MAC layer things. So, just to recompile what we are discussing. So, what we are looking at, the data link layer is primarily responsible for hop to hop transmission of the things, right, like from one hop to another hop, that how the data will be communicated, right. And so, whatever the upper layer things coming up, right, the data link layer, when you transmit the things, it opens up at the packet at the data link layer level and try to find out that what is the next layer to, next address to be pushed into, and push the data to the next. So, it goes for a hop to hop layer. It is in the same transmission, same what is a broadcast domain, but different collision domain. It allows multiple access to this overall multiple access to the media, and also we have seen LLC for the higher level connectivity and the MAC for the medium access type of connectivity, right. So, with this let us conclude this lecture, and we will be continuing our discussion on this data link layer protocols in our subsequent lectures. Thank you.